Okay, so we're doing volume, and we just said it's kind of how much something would hold. So think like how much water is going to fill it up. And just remember, there's a big difference between volume, which is what we're doing today, and surface area, which is what we have been doing. So surface area is going to be like how much covers it, and then volume is going to be how much fills it up. But super easy. So volume for prisms, remember prisms have to have two parallel bases, is just going to be the area of the base. So that triangle, the area of that triangle times how tall it is. So like from base to base, how tall is this prism?
22 meters.
Yeah. So let's actually just jump right in and do this example. The lesson that I have for you today, we've done maybe a couple like Desmos students in class where it kind of leads you through things. That's what your lesson is today, and I'll get you started on it. It's kind of cool though, because you can I put the tables in the slides, and then you can just write with your finger on the slides. Okay, so if we're looking at this, what shape is our base on this triangular prism?
A triangle.
Yeah, so I'm just going to kind of draw it here because it makes it a little bit easier. And then are we okay that the base of that triangle is 24 and the height of that triangle is 7?
Yep.
Okay, super easy. How do you find the area of that? So how do you find the area of that triangle?
Isn't it you'd have to do the Pythagorean theorem to find the other side, and then you can add them? Or no, that's a prism.
You're totally on the right track. Just think what's the formula for the area of a triangle?
Half base times height?
Yeah, good. And remember, little b and big B are totally different things. So big B is the area of the whole base, and then little b is just the length of the base of a triangle.
Okay.
Okay, so plug them in. So since you're right, do Pythagorean theorem here, but that's not going to help us with volume because we just need area of the base times the height. And if we're doing a triangle, as long as our base and our height make a 90-degree angle, you're good to go.
Okay.
So what would you have? Plug them in there.
Half of 7 times 84.
Mm-hmm. Okay, so you get 84 there. Cool, that's the area of the base, and then you just need to find the height. So what's the height from base to base? And I think you actually already told me.
Yeah, 22.
Okay. So all you have to do here for volume is you're going to do base times height. So do your 84 times your 22, and volume is actually easier than what we've been doing.
1,848.
Perfect. Okay, labels though, make sure you're calling this meters cubed because it's volume now. So area is going to be squared, and then volume is going to be cubed.
Okay.
Super easy. So that's the first part. So basic prisms, you're always just going to do area of the base times the height. Now, if we were doing surface area for this one, you were right. You would have to do Pythagorean theorem because kind of think back to the tables we did the last couple days. Don't they have you need the perimeter of the base?
Yeah.
Yeah, so if we were doing surface area, I agree. You'd have to do Pythagorean theorem and find this guy right here. But since it's just volume, area of the base times the height, super easy. Okay, so next part is pyramids, and I should label this actually. It's the same for pyramids and cones. And the difference is only that it's just 1/3. So a cool fact, and you're actually going to figure some of it out in your lesson today, but isn't area of the base times the height the same thing we did here?
Yeah.
So if you have a cone, it's just 1/3 of it. So like if you had a square pyramid and then a square prism, and they both had the same height and the same base, the pyramid would just be 1/3 of the prism. So kind of cool. So 1/3 base times height, same thing. But now you're just going to divide it all by 3. So let's do this cone. What shape is our base?
It's a circle.
Okay, perfect. So we're going to draw our circle here. You okay that the radius of that circle is 6?
Yep.
Okay. And then what's the area of that base going to be?
Pi r squared.
Yeah, you're rocking this. Okay, so if I plug that in, plug in your 6, what's our area of that base going to be?
113.04.
Okay, let's leave it in terms of pi. You're right. But multiplying
Okay.
it out, it just makes our answer a little bit less accurate. So I'm just going to leave it as 36 pi. That okay?
Yeah.
Okay, perfect. And then here's where it gets a little bit tricky. So we need the height, and I need to change that. So the height needs to be from the middle of the base to the point. Okay, so from the middle of the base to the point is this dotted line right here. Do we have that?
No.
No, so that's when we're actually going to have to use Pythagorean theorem. So think this
Okay.
10 is the slant height. That's what you'd need for surface area.
Mhm.
This right here is the height, and that's what we need to find. So you're going to have to use Pythagorean theorem to find it.
Okay.
And then that's easy. How do you want to set that up?
You just do x squared times 6 squared equals 10 squared.
Perfect. And then we'd have what? X squared.
X squared, 36.
Yep.
And then 100.
Good. Keep going. You're rocking it.
And then 100 divided by 36. That was. Oh, wait, no, I'm not.
Yeah.
Subtract. Which would just be 64. And then it'd be 8.
Bravo. Okay, so our height is actually going to be 8. So now we can kind of go through and plug things in. So this should be the height. It's from the middle of the base to the point. And I'll change that on my charts. Okay, so height here is 8. Perfect. And then all you got to do is literally plug it into that formula. So we know the total volume is going to be 1/3 times the base, which we know is 36 pi, times the height, which is 8. So I would just multiply your numbers and then tack a pi to the end. That's going to make our answer a little bit more accurate.
Okay. 96 pi.
Cool. And then what should the label on it be?
Is it in meters?
Yep. I don't know.
Oh, meters
Inches.
cubed.
So yeah, inches
Inches cubed.
Perfect.